Short little video on spherical mirrors after we've now spent a little time using the light box, looking at how light is reflected off of them. We're now going to get into the more technical aspects. Make sure to follow along in the textbook, section 25.4. Please look at the examples in there. They're very helpful. Let's begin. So there are really two types of mirrors here we have that we'll look at. Well, actually, there are three types that we will be concerned. There's a plane mirror, that's flat. There's a concave mirror, and there's a convex mirror. A concave mirror, we already know what a plane mirror is, a flat mirror. A concave mirror curves towards, the curve is towards the side where the light is coming from. A convex mirror curves away from the side where the light is coming from. So if we look here at our diagrams, concave is the one kind of in the middle of the diagram here, and we have the light coming in and it is reflected back towards the direction that the light's coming in, towards like it's towards the center of that circle of a concave mirror. The convex mirror reflects it kind of way. It's actually what we call it disperses the light. There are two parts of the mirror here, the measurements that we're really concerned with. The radius R, and center of curvature, C. And we'll see in a second how these are related to the focal point. We will assume that all of our sources of light are far enough away that with respect to the mirror, that the light moves into the mirror parallel. All the rays are parallel to each other. And as you think about our light boxes, when we put in that filter, or it's actually kind of that, what is it? The multi-slit filter that it's only the light's moving through the slits. So then you get all the light going in those straight lines. The focal point for a mirror, for a curved mirror, in a case of concave mirror, is equal to 1/2 the radius of this, the radius of curvature. And so this depends. So a very curved mirror has a very sharply curved mirror has a very close focal point, whereas one that's a much wider mirror has a focal point that's farther away. And when we start drawing ray diagrams, you'll see the effect that this has. Spherical aberrations occur when you have a mirror that has a large curvature or a large, we'll say, size, and so it curves for many degrees, goes around, or you think about just a bigger mirror. Within a spherical mirror, the light that's reflected off the far edges of the mirror it's not always directed back towards the focal point. This is called spherical aberration. The fix of this is to use what's actually called a parabolic mirror. So, and if you can look at the diagram here, most of the light directed close to the center, towards the radius, is reflected right back to the focal point, whereas the stuff directed very far away is directed, the light incident far away is really just off. You could say it's off. And this is what spherical aberration is. One quick little question here. I just really want you to make sure you fully understand, and this is just a check. How are concave and convex mirrors different or similar? How are their focal points different or similar? How is their construction different or similar? So think about this within mirrors, and I want you to write down and come up with as much as you can about how concave and convex mirrors are different or similar.